Okay, so what's the solution when you have such a high-dimensional integral to deal with? As soon as you have more and more factors that are uncertain and you collect data for, or sometimes if you don't have enough data, you build a model for, right? Like if you only have very sparse data, you can model it as a Gaussian or exponential or something, right? What do you do?
Make assumptions.
Like what?
It's you use like a mix between their method and our method. Like you can fix some variables.
No, use Monte Carlo method. That's the topic we want to discuss today, right? So Monte Carlo method actually originates in statistics in a scenario similar to this, where this is an example I posed when in the world today we have plenty of data, right? So a lot of the random variables in this example are actually random variables we can directly sample from a huge data set. In the classical Monte Carlo method, when people used to teach it, all these variables are assumed, right? X1 is Gaussian, X2 is uniform, 0, 1, and things like that. And then the question is to perform a certain high-dimensional integral involving all of these random variables. So Monte Carlo method is good at just one thing: performing a very high-dimensional integral. That's it. All right. So whenever you want to integrate some function in one dimensions, no brainer, just discretize the function and use a quadrature, basically count the area beneath it. If you have a two-dimensional integral, you should still discretize it and just count the area underneath it is still a good idea. Okay, especially if the function is smooth and you can use something like trapezoidal type of approximation for the area. Whenever things goes to 3D, 4D, 5D, 10D, 100D, the traditional type of integration methods no longer works efficiently. And the only way we as a species knows how to integrate such a high-dimensional functions is to use this miraculous property of randomness, is to draw samples and average. So how does that work? In this particular example, how do you integrate this, for example, two-dimensional function using Monte Carlo? Anybody give a suggestion? Well, each of you has a paper in front of you with random points on it.
You drop random points on the graph and count how many are inside the space you're trying to integrate over.
Exactly. So basically, Monte Carlo method just starts with drawing random samples. If you have, in this case, two random variables, just pick a few combinations of these random variables. Okay, maybe the number is 10, maybe it's 100, maybe it's 1,000, depending on how many you can afford. Okay, and then count. In this case, I'm just counting what percentage of these random choices of random points is actually feasible for my design. And we are going to look at the error analysis next lecture. But like if you want to have a 99 percentile probability of success, right, you probably want to draw thousands of samples. But the good thing is that these thousands of samples actually doesn't really depend on how many random variables you have. if you have 100 random variables, you have to draw the same 1,000 samples, right? You basically the cost of a Monte Carlo method. That's kind of the almost the single most biggest advantage of Monte Carlo method is that the cost of Monte Carlo method has no dependence on the dimensionality of the problem. That's pretty amazing. So you draw the same number of samples no matter if you have 2-dimensional space or have a 100-dimensional space. And then you basically figure out for all of these samples, what is the percentage that actually works. Okay, so that's our case. We want to integrate an indicator function. If you want to indicate another function, right? So for example, each trip is going to cost a certain amount of attrition on your quadcopter, no matter how you kind of account for the attrition, right? Let's say it's decreased the utility of your quadcopter by a certain percent. If it goes from 100% to 0%, you have to replace the quadcopter. Then what you want to calculate, instead of integrating this indicator function, you want to indicate another different function that computes how much degradation the trip cost to your quadcopter, right? In that case, you would be also drawing random samples, and then instead of averaging this 1 or 0 function, right? Averaging this 1 or 0 function is basically count the percentile of this function being equal to 1, right? Now, instead of averaging this 0 or 1 function, you average a different function that accounts for the attrition, and that'll give you the expected number of trips your quadcopter is able to make for its lifetime. So things like that is what Monte Carlo method is good for, okay? And so this class is really just the introduction, and next class we'll formalize it and exactly figure out if we actually want to make this particular calculation and make similar calculations, how many samples do we actually have to draw to figure out, to have a good enough confidence that my quadcopter can make it 99% of the time. All right, so see you on Wednesday then.